One thing very important in statistics is something called a normal distribution. For information purposes, I'll go ahead and give you the equation for a normal distribution. This is the equation that it looks like, but we talked about it briefly before, and its another name is a bell curve because it looks like a bell. And when you graph this, you get this across the y-axis. But when we're looking at data, generally speaking, its middle part here is the mean, the average of the data. And this is a precise mathematical model, this here, for normal behavior. So we're not actually going to use the equation very much, but we are going to look at this graph. So on a normal curve, standard deviation is 1, and about 68% of the area under the curve is 1 standard deviation away. So if we have this and we go from -1 to 1, then if we look at the area under this curve, that's 68% of the area. And then if we look from -2 to 2, then if we take all this area under the curve, that's 95% of the area, 2 standard deviations away. And if we look from -3 to 3, then we have 99.7% of the data. So what this says is in a normal distribution, most everything is bunched near the mean, and almost all the data is within 3 standard deviations of the mean. Now that's kind of complicated, and a lot of statistics stuff, and a lot of this area stuff is calculus stuff, so we're just barely touching on this. So don't feel like it's overwhelming and you have to know this stuff inside and out. But right now we're just introducing it, and you need to know kind of the percentages of what's between 1 standard deviation away is 68%, and 2 standard deviations is 95%, and 3 is 99.7. You need to know that. But the other thing we're going to talk about is, and your book makes a big deal about this, the Bob Jones book does, is something called a z-score. And the z-score is how many standard deviations it is away from the mean. And your book has a big chart on page 469 that helps you with the z-score, and this is a calculation that we're not going to get into and all that kind of stuff, so we're going to just use the chart because that's a lot of calculus that we don't have the ability to deal with. The other thing we're going to look at a little bit is a percentile rank. And that's the percent of values less than or equal to a given value. And when you take like ACT or SAT or any of the standardized tests in the Terra Nova, any of that stuff, you get a percentile. And what that's saying is that the percent of values less than or equal to your score. So if you have a really high percentile rank, then that means that most of the scores are less than or equal to your score. It means you got high score comparatively to other people. Okay, it doesn't actually tell you how well you did on the exam. It just tells you how well you did compared to other people. It's just a statistic. So let's do a couple of examples of stuff with the z-score. So we have, let's say we have a z-score between -0.74 and 1.13, and I want to know the percent of values in this interval. So I want to know, if I look at my curve with my statistics, if I'm looking between these z-scores, then what is the percent of the area under the curve, because the area under the curve tells you how many statistical points you have for that score. So if you look on your chart on page 469, you'll see that it has the tens place down the left-hand column, and then it has the hundreds place across the top. So you'll go down to the 0.7 on the left, and then over to the 0.4 on across. So you see that it's 0.2704, and you say, well, this says negative 0.74. Why would I be looking at that? Well, if you notice, this is an even function. So across the mean, it's the same. So whether you're going from 0 to 0.74 or you're going from 0 to negative 0.74, you're going to get the same value. So you look up on your chart for 0.74, and that tells you from 0 to 0.74, and that gives you have 0.2704. That means 27% of the data points are between 0 and 0.74. Then we're going to look from 0 to 1.13, because that's going to give us the area we need on this other side. So here what we're looking at is a z-score where we're looking from about here to over here somewhere, and we want this area in here. So we found this one on the left-hand side to be 27%. And so now we have to find the one on the right-hand side. And again, we use our chart. So we go down the left-hand column to the 1.1 and then across to get to the 0.3, and we get 0.3708. So that means 37% of the data is there. So we added up 27.04% plus 37.08%, and we get 64.12%. So what does that tell us? Well, that tells us that if we are given a set of data and it's a normal distribution, then between negative 0.74 standard deviations away to the left of the mean to 1.13 standard deviations, however much the standard deviation works out to be, then we will find the area under the curve, how many data points are underneath there. And so we find that 64.12% are there. So what if we want to go the other way around? What if we want to find the interval of z-scores around the mean that contains 38.3% of the value? So what we're looking for is we're looking around the mean, and so what we want is for this area here to be 38.3%. So you have to divide it by 2, because this is going to be 19.15%, and this is going to be 19.15%. Because remember, our table of values is only giving us from 0 to that value, since it's an even function. So I hope you're on page 469 looking at that. So we look at the table, and we see, if we look around for the 0.1915, we see that that corresponds to a z-score of 0.5. So what that means is that for our z-score has to be between negative 0.5 and 0.5. So between half a standard deviation away from the mean, we're going to get 38.3% of the value. Now, you may say, well, one standard deviation from the mean was 68%. Shouldn't it be half of that? Well, no, because it's not like it's a square or something where we're dividing it in half. We're dividing this bell curve in half. It's a little bit more complicated to find the area. It requires some calculus. So it is not going to be exactly half of that. So look on the chart for your z-score. Now, what if I want to find the percentile rank of a student with an 85 in a class? So the student's grade is an 85. And the average of the class is a 78. And the standard deviation is 8.4. So that means the standard deviation is how far it averages, how far away from the mean data points can be. And when it's kind of complicated and more than what we're going to cover. So it's just a measure of variability that we use to find the z-scores and those kind of things. So a z-score we find by taking our score and finding out how far away from it is from the mean, and then we want to know how many standard deviations it is away from the mean. So this tells us how many number values it is away, and then this tells us how, this is kind of an average of how far away it is, but not exactly. So we're going to find how far away it is, and we want to know how many standard deviations that is. So we divide by what a standard deviation is, and we get 0.83333. So we look at the chart, and we find at 0.83 we have 29.67. So from 0 to 0.83 gives us 29.67% of the data. So what that's telling us is our data is distributed like this. So at our score here, then this area here is going to give us 29.67%. Now we want the percentile, so we want everything less than this. Well, this is 50% of the data. So we add 50% to that, and we get that our percentile rank is 79.67, because this whole area, all the way up to our score, is 79.67%. So this is the average here, so this would be 78, and this is our score. Everything below it gives us the percentile. So, normal distribution. The biggest things that you need to know about normal distribution is the shape, the percentages of what's where, and you need to understand about the z-score. And the z-score is how many standard deviations it is away from the mean, from the average. So it tells you, it kind of gives you on the scale of the normal distribution. And one standard deviation away, one z-score, the z-score of 1 is the 68% of the data. On your chart, you'll notice it'll say 0.34, but remember that's from 0 to 1, so you have to double that. So you need to know that. You need to know how to find the z-score. The z-score, remember, you're taking how far it varies away from the mean, and then dividing it by the standard deviation so that you can find out how many standard deviations it varies from the mean. So make sure you've read over this section, but don't sweat it too much. If it gets a little bit complicated, do some of those problems and make sure you know how to find the z-scores and the percentile rank and those kind of things.